Okay, let's put our method for evaluating scalar surface integrals to work. Here will be our first example here. Evaluate the double integral over S of x squared z d sigma, where S is the part of the cone, x squared plus y squared is equal to z squared, above x squared plus y squared is less than or equal to 4. So this problem should feel a little bit familiar because we actually found in the last videos, that last set of videos, the last section's worth of videos, we found the surface area of this. We found the surface area of this cone here. And as part of finding the surface area of that cone, we had to parameterize it. And so I'm just going to go ahead and write down our parameterization here. And our parameterization is going to be, let's see here. So r of r comma theta. So, it's essentially kind of playing out along the same way as with polar coordinates. And so x becomes r cosine theta, y becomes r sine theta, and then z becomes, in terms of x squared and y squared, z becomes r squared. Okay, what are the bounds here? Theta runs from 0 to 2 pi, and r runs from 0 to 2. Okay, let's see here. Following our chart, we got our parameterization. We need this set of information here. We need this set of information. And again, I'm just going to appeal to what we did previously and say that the magnitude of the cross product r sub r cross r sub theta is going to equal square root 2 times r. And so then our integral that we are doing here, the integral that we are evaluating, the double integral over S of x squared z d sigma is going to equal, okay, we need to replace, so this chart says here that we need to replace x, y, and z with the parameterized versions of them. So x squared becomes r cosine theta squared times z. Z becomes r squared. Oh, I'm sorry. That should just be an r there, right? Because this is r squared is equal to z squared, so z is equal to r. Sorry, miscopy that from the notes. Everything else here is okay. So x squared times r. And then we throw in the factor of the magnitude of the cross product. We throw in the factor of the magnitude of the cross product. And so square root 2r dr d theta. And don't forget to include the bounds here, that r runs from 0 to 2, and theta runs from 0 to 2 pi. And so our scalar surface integral, we put it down into this relatively easy to evaluate double integral here. Theta runs from 0 to 2 pi. I think we could split off the theta stuff. The only theta that we're integrating here is cosine squared theta. D theta. R is running from 0 to 2. We have r squared, r, and r. So we have r to the 4th here. And then there's a factor of square root 2 that I'll just stick in there. Okay, the integral from theta is equal to 0 to 2 pi of cosine squared theta d theta is pi. And then this right here would give us square root 2 times r to the 5th over 5. Plug in r from 0 to 2. And so we have 32 square root 2 over 5 pi as our scalar surface integral.